So welcome everyone to Sky 360 demoing time. Today I'm going to demo the latest work on creating a camera node, and I want to show you and run you through what the camera is doing, the fisheye camera I'm talking particularly about, and talk with you about where my issues are with this device. Okay, so first of all, I started. Can you see my command windows colors?
Mm-hmm.
Okay,
Yeah.
cool.
Yes.
So what you see is I first clean up the shared memory, then I do a USB resetting because I found out it helps in certain cases. I give a lot of time for the SDK initialization, I think 5 seconds. But you know, it's just for boot up, for starting the camera, so I don't give any damn about long timing. And now it started to do some grabbing for single frames, and now it goes into live mode. And what you see here is a window that opens. It's a CV window, open CV. And what you see is that the auto exposure is working and trying to find the sweet spot for the lowest brightness error. Okay, now it's stabilized, and nuances of light changes are catched by thresholds, so it does not flicker all the time, but really changes when there's significant change in light. So for example, if I take a light source, and you see that gain is raising up because exposure can't raise up. Exposure and gain are both gated on boundaries. So exposure goes up to 110,000 microseconds, which is 110 milliseconds. And gain has its sweet spot at 22 decibel. So as the rule for the auto exposure is as long as exposure can be adjusted without going out of bounds, gain should stay close to 22 decibel. So what you see here now, extreme changes that are not taking place in nature. My question was just how quick does the auto exposure adjust to light changes? And it takes, I think, 7 cycles until this loop back. Yeah, and it is overshooting, as you see. So what you've seen now, it's coming back from a very short turn timed exposure to a longer timed one because I turned off the torch light. But the adjustment was overshooting, but at least not oscillating. So what I found out so far is I tried 15 different ways of controlling auto exposure, and I'm now at the, let's say, the straightest one, the very easy one without many rules, just one rule and conditions that are set on this rule. So 5 conditions set on one rule. Because I found out that's the fastest way to do it, the shortest number of cycles that are used to adapt, and not to oscillate. Because the shorter the time you make, the higher the risk for oscillation becomes. I did 15 different auto exposure algorithms. I tested several that are promoted on the internet on some papers, but they all have the same issue. The closer the faster, the agile you make it, the more you do it into overshooting and oscillation. So it's a kind of, for me, at least so far, maybe someone finds a better auto exposure algorithm, but for me, so far, it's a kind of a balance between how agile is it and how stable is it, or is it going into oscillation, overshooting. So this one right now is a little bit of overshooting, and I can control it now, and I will show you how. Bye-bye, by the way. So as you see, Carlos, I'm closing everything, closing windows, stopping live camera activity, stopping the cooler inside, releasing the SDK, and then closing the camera and even cleaning up the shared memory. So everything is nicely for a nice restart. So this is a graph that is reflecting the latest version of the auto exposure. The number 40 means that with every cycle, only 40% of the brightness error is compensated. The next version will be with 50, with 60, and so forth. So I want to have an idea how this particular version of the auto exposure is adjusting dependent on the amount of brightness error that's compensated. Of course, you can do this with damping and smoothing, and I did this already, but it turned out it became more complex and less correct responding. So a EMA smoothing was something that I put in, which did a good of smoothing the errors into a correct brightness error. So what you see here is a cyan colored line, which is the current brightness. We start the camera with a little bit dark scenery, so there's not much light here, and that's why it's around, I don't know, 30%. It's 0.3, so it's in percent, 30%. The optimum point is 0.5, so 50%, right in the middle. Now it's on optimal here, but it starts dark, and you see it is adjusted quite nicely, this curve. What's happening is that exposure is started first. That's this dark green curve going up. It's actually rather slow. It takes over 60, even 70 cycles to adjust to the maximum. And even there, because it's only 40% of brightness error, not even gain is jumping in, because the brightness error is too small for gain to jump in to compensate for the rest of brightness error there is. Because you see from the ramping of exposure where the actual brightness error sits, because exposure wants to go a little bit higher, but then it is flattened out because it's not allowed to go over 110 milliseconds. Otherwise, we would infringe the sync of having a target FPS. So it would run out of sync. So it is sealed with a sealing. But you can imagine where the curve is going. So this little amount of where the curve wanted actually to go is not even compensated with gain, because that's only 40% of the brightness error to be compensated with. So next version was with 50%. You see again the light is adjusted nicely. About 12 cycles, it's on optimum. 12 cycles, it's an optimum. Could be faster. Would be nice to have it faster without oscillation. What you see on the red curve is the error of brightness. How much wrong, how much off is the current image from an optimal distribution of a histogram. So what I did is using a histogram and using edge points on the histogram. I took 1%. So what? I took it from scratch. I took the whole picture, and I sampled every fourth pixel out of it, just for performance reasons. So I do not take the 3200 by 3200 image. I just grab every fourth pixel. Then I do a graying. Then I do a histogram. And then I'm doing a finding in the histogram the max point for black and the max point for white. So to stretch it. This is done by a procedure, it's called CDF, where you control the the amount of blackness and the amount of whiteness, let's say. So you say, when you make a histogram, you define how many slices or bars you want to have in your histogram. So how much is it inter-sliced in how many sections? And I used 512. So we have, if I take 1% for black, it means everything which is in slot 1, 2, 3, and 5 is pure black. And everything that is beyond 507 of these slices, 507, 508, 9, 10, 11, 12, which is white. Meaning we can control by this we can even reduce the fluctuations in light, where real black is never real black. Just to say, from this point on, it is real black. Did you get what I mean? I hope so. Hard to explain. Mm-hmm. That's a factor. That's two factors we can control with. So either dragging it down or dragging it up to find the points whereof it's the outside boundaries, you could say. From there it's white, and from below it's black. Yeah, so what is calculated then is the actual brightness error, and the brightness error is the from this histogram, the optimal point is set as 50%, right in the middle. We can change this. We can change this even on daylight or nightlight situations to say where the balance, the midpoint is. For now, I say just in the middle. So the optimum point for lightness is 50%. But it could be in darkness that the optimal brightness is 60% or even higher. And this would have an influence, of course, on the whole auto exposure behavior. But at the end, brightness error is calculated as always, and there's a certain threshold where it is not necessary to go beyond, because this influences oscillation again, or overshooting. So what you see here is it is not overshooting, it's nicely damped, but it's rather slow. It takes 12 cycles to be at the optimum 50% brightness point. So now I go from 50% brightness error correction, also compensation, I go to 60% compensation per cycle. It's just the amount of how much error is there left over and how much do I go to compensate in this cycle. I could do 100. I did 100 at the very beginning, but it was only oscillating. It was because the thing is, and you see it in the next graphs, that it is a timing issue. Because when I evaluate the image for the auto exposure, this image is old. I set it for the new one. And then I get the feedback from the new one, and I set the next one for the next one. So I'm always running in behind. And there are algorithms that do an estimation ahead, which I found to be rather complicated. And yes, we could go there, but for a start, just to have a working AI, such things were a stretch for me, let's say. So I said, okay, I think we need something that is straight, fast, agile enough, and damping enough, because looking with the camera in the sky does not mean that the light is changing every second. So to have a IA controller that is even more agile for shorter periods, for me it doesn't make sense, because it only influences oscillation and overshooting. So yeah. Okay, what you see here is it's about 12, what I said, brightness, and you see the error is leveling out at a certain point of, I think it's in percent, it's less than 1%, sure. Because this is by 100, by 100. So 50, if it's 50, then it's actually 0.5. Right. So if it's 1 or 2, it's 0.01. Okay. 62%. And you see the difference, which is interesting. The light scene is not changed from test run to test run. But changing from 60% to 62% is a difference in behavior. You look at gain. Gain is the blue line. Gain is not, because 60% of changing something which is a little bit overexposure here is not much of a energy that needs to be compensated with. So gain stays as it is. Only at 62%, then it starts to say, which is also interesting that this goes up that fast, and then where's the rest? But it kicks in gain at least. The optimal point is again around 12 cycles to be at the sweet spot. On 64, we already see overshooting. Wow. Normally it's stamped right over. It stays over 0. I can go back one. So with 62%, you can see a little bit of overshooting, and with 60%, there's almost no overshooting. But if I go back to, and let's keep forward, 64, it's heavily overshooting. And the only difference that I did is changing the amount of brightness that is to be compensated per cycle. And what astonishes me is how little a percentage can be to create a very over-exaggerated auto exposure. But in this graph, you can see the timing. That's the current situation. That's the current brightness in the current era. And gain is running in behind. Gain is timely running in behind. It levels out later. That's something we can improve in the future. That's the 70, even more overshooting and even more running in behind. 80, even worse. So you think if with every cycle, I compensate for 80% of the error, it should be fine, wouldn't you? Because in every cycle, you jump to the next, but this means that the image is not changing. In this case, when you change the exposure, you change the next image. So the image is not the same, meaning you're always running kind of behind. Yeah, and the extreme is 90%. Okay. Basically, that's it what I wanted to show you. Carlos, these are for now the parameters that are fixed, that we have as entry points, that can be controlled via a ROS node. So to say, I start this node with a certain exposure max, for example.
Mm-hmm. Yeah, so currently I've put those as constants on the class.
Yeah, the question is, we should be able to start them, because I think we have certainly a difference in daylight and nighttime behavior. And I think even the cooling situation could be adjusted as well, if need is. So I think it doesn't it doesn't hurt if we have some parameters we can call a node, and it starts with this parameter.
Yeah. But it needs to reset, right? So it needs to switch off everything, change for the new parameters, and then switch on again.
Yeah. Yeah, anyhow. Anything more important I want to show you is, there's only a min step and gain min step and a exposure min step. So this is something we certainly need to control. Where is this? Here it is. So these are, for me, are important parameters. So how fast do you use exposure on daytime or nighttime? You know?
Mm-hmm.
Because actually the whole theory behind auto exposure is use exposure as much as you can and gain as less as you need. And keep gain at a certain point, which is its sweet spot, meaning where its electrical efficiency is highest and the amount of noise is lowest. Something like this. So Christian gave me three graphs about this, just to find out that from this particular camera, that the gain at 22 is optimal. That's what is reflected here. Gain is 22, which is the optimal point. One thing for temperature control I wanted to say is that, where's the temperature control function? Yeah, here it is. Actually, what I found out with this camera is just you have to set the target temperature, and you don't have to do anything. What I'm doing here is every 100 frames, I make a check with the temperature cooler, just to say, what is your current temperature, what is your PWM, and what is your target? And set the target again, the very same target. So I set minus 20 degrees as the very same target. And what I found out that this camera, the electronic inside is perfectly iterating towards minus 20 degrees, a little bit of overshooting, but it finds back to within, let's say, 1 or 2 seconds to the optimal point. And because temperature control is something that you only initially need, well, how much strong temperature differences do we have in nature? If it, Yannick, you can tell us, how fast can temperature change in the atmosphere, near the ground level?
Near the ground, yes. If there's a cold front coming, it might be, I don't know, maybe up to 10 degrees in half an hour or something.
Yeah, see, that's what I mean. It's extreme for us, but
I mean, it depends where you are on the planet, of course, but that's just something that I seen here in Germany.
Mm-hmm. Yeah, but what I want to say is, of course, you can have higher differences in degrees, but the time it is taken for the impact of this temperature to become this, let's say, 10 degrees, takes a long time. You don't have this in the second.
Yeah.
It does not happen actually normally.
No.
Does it? 10 degrees in 1 second? No.
Yeah.
So.
No, definitely not.
I think we can track this back to, let's say, every 200 frames or so, check it. And basically it iterates towards the optimal point very quickly within, I call it every 100 frames, so it takes a long time before the next update, but it takes only, I think, 5 updates to be at the sweet spot. So I think we can just start it with a certain temperature and then control it once an hour or so, something like this. You know what I mean, Carlos? That this is not part of controlling of the temperature, just that you initialize it with this temperature and then forget about it. And controlling the temperature could be a kind of a ROS command that another node is giving it. Tell me, what is your temperature? Carlos?
Yeah.
What do you think about it? How would you do it? How would you, for example, controlling the temperature? You understood what I just said.
Yes, yeah.
I said it every 100 frames, but it's not necessary to do so because the camera works perfect. It does it in a very short number of cycles. We just have to control it, whether it's there or not, every once an hour or so. I don't know. But the question is, does this need to be part of the node itself, controlling itself, or is this something an outside node is controlling to say, give me your temperature? What is your temperature?
This can be internal, so, and at least I put it in there as a function as well. And this runs during the live camera, so it captures. So yeah, it can be there. And we can put as a parameter as well, so that we can control. So we can log the temperature, so we can see it, and then having the ability to adjust out externally.
From outside, from another node.
Again, here, here the question is, so this is changing in live during live, so we don't need to reset if there's a big change. Yeah.
Okay, got it. Yeah, actually that was it. that's it. I want to show you. Next thing is that I think, Carlos, we need to sit together and talk about how we set it up on GitHub so we can commit there. Well, okay, when we are off record, then we talk about when we do it. Just one thing I want to show you is how you certainly have understood the code, because I know that you have read it. What I'm doing here is I'm creating, first of all, a buffer, which is this cycling buffer with this frame index that's cycling through. But I used a secondary buffer for the metadata running on the same frame index. And I added not only the current time, but also values like, in this case, exposure and gain, because I think for the data to be stored with, we should know about the amount of exposure and gain that resulted into this particular frame. Yannick, do you know what I'm talking about?
Yes, I think so. So I mean, I get the roughly the idea, I guess. Yeah. I haven't seen the code. I see it now for the first time, right? So
yeah. Now the thing is, there are two buffers, and one is for the data frame, and one is for metadata. And what I'm doing so far is using only 3 parameters, which is the current time. So if we have a timestamp, the current exposure, and the current gain. We can expand this if we take temperature, for example, or whatever Christian comes up with to put in this. So we have actually 2 buffers that are shared via shared memory, and can be used by any outside software. And because this is a loop of 200 frames in this case, because I do it for 200 frames, which is set somewhere here. Ring buffer size is 200. So whenever it goes to 199, it goes back to 0. There I do only one simple thing, Carlos. The auto exposure is just looking whether frame index is modulus a certain interval. So every 6 frames in this case, because exposure gain interval is, I set it to 6 frames. So every 6 frames, there will be a cycle, an update cycle on the auto exposure. The very same is true here for the temperature control, where I did it in this case, but we don't need it anymore here because as we have spoken, we did do it differently. I just wanted to say that I control it by the frame index when I start stuff. Okay. Any questions?
I think I had already these 2 in the last code that I looked at.
In what?
Yeah, I think so. I already had this. The codes that you gave me, the reference that I took to work on the class, I think it already had these two if statements, one for the auto exposure and the other one for the temperature.
Okay.
Yeah.
Yeah. So the question is, do we need air temperature, or shall we skip it? The internal automatism. Control it. Do we need it?
Yeah.
Yeah. Okay. We can keep it there.
We can check.
We can later remove it if it's not needed.
Yes. Yeah.
Yeah. Actually, this is something I wanted also to discuss with Christian, so that he has a say in this as well, because I'm not quite sure whether we comprehend everything the camera is capable of. Yo, yeah, there's a lot of things that you do not need, but if we stop the camera, we have to do some things in the right way. You know, it's the same for a lot of things. You have to stop them the right way. The other way around that you start them. Okay, guys, I'm going to stop recording.
Yeah.
Or is there any other question that should go on record?
I don't know if it has to be on record. I just have a question regarding the auto exposure. It definitely looks good to me. But which one did you choose now? So you showed us different settings, I think, right?
Okay, I started with.
And so what was your decision criterion on which one to choose, basically?
So I tried, I think, 15 variants of auto exposures. Going from
you said you had different algorithms, right? But you showed us these your plots.
Yeah.
And
last algorithm.
It was from the last, and you had different settings basically that you went through in these plots, right?
Yeah.
And which one did you deem the best, basically? It's
62.
And okay.
62%.
Okay.
Because the next one is overshooting, highly.
Yeah.
And the previous one is not even touching. So this is right at maybe 63. Yeah. But this is academic. We have to test it on this is my setting here, okay? I do not have daylight, I do not have nightlight. I have one setting. I just needed an auto a controller that is being agile, is not overshooting.
So it needs 15 frames to.
It needs 15 cycles, not frames, cycles. And because I kick it, I update it every 6 frames. Means if it takes 15 cycles, 15 with 6 is 90 frames, and by 7 frames it's 13 seconds, something like this. 13 seconds.
Yeah.
But this is a.
Okay, I misunderstood the frame index then.
Yeah, it's not the real frame index from the data coming in. So I'm grabbing the 7 frames per second, and let's say once per second, just to make it simple, once per second, I do an update on the auto exposure. So I have 7 frames per second, but I do it every 6 frames I do it. But anyhow, it's about once a second I do an update, and that's why if it takes 12 or 13, 12, let's say, frames, it means it takes 12 seconds.
Yeah, I think for normal outdoor light conditions, that's good, right? Yes.
You have to consider this is a strong difference in brightness. So we have here, it goes from 25% to 50%. So it's a quarter of light of the situation, of the scenery that is raised in this case. It's a lot. So how often does the sky change by 25%?
Yeah, exactly. That's what I meant. Yeah, for auto light conditions, I mean, they usually don't change very quickly.
Yeah, and in this, yeah, right. So that's my my setting is here on the table. I only have one. I have a lot of lights here actually, computer lights and blinking lights. But the condition of these computer lights is always the same. No matter whether I do it yesterday or today, because the devices are all the same and they have the same light. So I can compare light situations from yesterday to today. In the evening, when it's dark outside. So not to have an influence from the outside. So I can say I have a setup here that I can control from a scene light, a light scene. It is a very particular light scene, but I can adjust an auto exposure toward a certain behavior in this very particular light scene. Of course, it can be that another light scene triggers another behavior. And this is just this setting. And of course, we need to adjust to daylight and night light. Or even in dawn, maybe or we integrate a kind of a logic that behaves and moves things within dawn time. For example, exposure time is 110 as a max, 110 milliseconds. You can't do longer exposure because you have a certain frames per second that you want to collect light with.
Yeah.
So
that would be 9 FPS or something.
Yeah, but
minimum
overhead of process time and so forth. So at the end, you end up with this is something I can share actually. If you look at the screen, where is it? Wait a sec. Where did I put it? Here it is. So I did an estimation about frames per second, cycle needs, and max exposure. Tested with this particular camera. And it gave me kind of an idea of max exposure. But it's an estimate because I timed every process, how long it took. There's a lot of time deltas that are logged. For example, time formatting. Here, for example, so I do one call and I log the time it needs for this call to start and to end. And I did this with all SDK calls and also with larger NumPy processes, let's say. Just to have an idea of how much time is consumed by the step in the process. And because you have a certain FPS, as a FPS you want to reach, you have a certain time amount that you can use. And if it's so much time is consumed by whatever process there is, by grabbing the camera, for example, the frame, there's only so much time left for the camera itself to expose. And there's a little overhead also, because when you set the exposure now, it is set for the next frame. You call the next frame to a different time when exposure is maybe already done. It has it done and stored in the buffer. And by grabbing the frame, you flush the buffer. So it's all asynchronous. Async. It's out of sync, let's say. Because you call it now, but the next frame is the one that takes it. It's not immediately, and takes up to 0.1 second. Only the grabbing take. Wait a sec. But I don't saying anything wrong here. Just a sec. The grabbing takes. Oh, I didn't block this one. I did it a lot of times, but not this time. Super. Oh yeah. I want to show you something and then I can't. Yeah. So something like this. Yeah, okay, I can't prove it right now, but I did in the past, okay? So, so many changes. Stopping the camera is just a call on the SDK, and what I did in the command is just the average time of processor. So I get in the code an idea of how much is where consumed. Anyhow, at the end, I know what is consumed and what is the rest, and tested this and went even further to have higher exposures than are leftovers by just a calculation. So to find a sweet spot of how far can you go, kind of. So if you take this target FPS, then how far can you go with exposure until it degrades in FPS? You get my idea? Okay, yeah. So by this way, I found out that these exposures are the possible ones. And for now, I target on 6 frames per second. No, on 7 frames per second. Ah, yeah. Actually, exposure should be at 90, but you see, 110,000 still works.
And is there more overhead coming, or is that? I mean, do we need to implement more stuff?
No, this is the max. No?
I was just thinking, what is the next? What is the next step, so to speak? For example, putting the camera outdoors and checking. But I was also thinking about, do we need to add a white balancing or something like that?
Okay. This is something we need Christian to talk about, because he has code for, I don't know, master bias, black field bias. I don't know even the names of these, whatever he's doing. He wants to implement, because he already has it. The thing is, he wanted it to implement. The thing is, we also have to control the camera by doing this. That's the downside of it. So we have to find, let's say in the 24/7 time cycle, we have to find some time when we do this bias recording. During this time, the camera is not doing anything else instead of bias recording. So for example, the black bias frame, or whatever that is called, is setting exposure to 0, meaning every frame should be 0, should be black. I mean, but still you get data, meaning there's over potential on certain spots on the sensor, and you have to control this via, let's say, 100 of these black exposures, and then you stack them, and then you see where real kind of defunct pixels are. Defunct is a bad word, because it is not working. It just needs a filter, a dampening, kind of. And it
sort of a calibration step.
Yeah. But we need to do is, let's say, every 10 hours or so, or I have no idea. Christian has to tell us. So, but during this time, the camera is not producing frames, and we have to stop everything.
Yeah.
Not the track has to be stopped. Everything has to be stopped. It has to go into a, I don't know,
calibration cycle, basically,
for, I don't know, 2 minutes, and then going back to life, kind of.
So it's sort of a self-calibration step that it does in regular intervals. But that's not what I meant. I meant some more overhead coming that impacts the FPS.
No. This is
so if there's any white balancing, depending on the light conditions, if it's cloudy or sunny or something like that, that's what
with auto balance,
I was thinking about.
With auto balance, you shift actually this spot. Where is it? Target brightness. You shift this spot. It's this. In this case, it's 50%. So that's what you saw in the graphs. This one, target brightness 0.5. So as much lighter pixels are there as darker pixels are there. So the amount of brightness is to the. So this is also has to be adjusted in daytime and nighttime. In nighttime, you certainly have much more dark pixels compared to white pixels.
Yeah.
That's certainly something we need to change, because that is, for now, it's hard-coded here. Target brightness 0.5. Anyhow,
so there will be a little bit more overhead coming.
No.
Sounds like.
No. There's nothing anymore in this camera that can prevent us from, let's say, 7 FPS.
Okay.
Because I already use the full frame. So actually, the full frame is 5,544 by 3,260 or 40 or something like this. And what we do is we take out a square of 3,200 pixels and forget about the rest. And the rest is only black because it's a camera. It's black anyway, so there's just I guess we only see the interior of the optic there. Yeah. So actually this is the max amount of pixels that we grab. We do it in a certain frames per second. It meanders around because I calculate a dynamic delay, because every frame is different in size and takes different time to run through the USB buffer. Meaning at the end I have a different timing for every frame I take. So I try to calculate a delay that I add on kind of a sleep. When the cycle of the main loop is through, I sleep for a certain delay just to keep the camera in sync. If I do not do this, after several frames, it would run out of sync and doesn't deliver anymore. So you really have to keep it in a certain. And this is also something very odd I found on forums, where people suggest that you first start with single frames. And I did this, and I grabbed a certain amount of frames. Let's say I start with 5 single frames, and I found out that the amount, although the light scene did not change, and the amount of data transported did not really change, that the time to grab changed. The first took longer, the second less long, the third a certain time, but then it is steady from the 4th and the 5th grab. So I found out to bring the camera in sync just takes 3 single frames to fetch, and then switch over to live mode and start live grabbing. Yeah. It works. It works when the camera is freshly booted and is not messed around during development.
Okay, so what would be the next step then?
The next step is that what actually already Carlos did. Carlos put it, turned it into a ROS node. What we now need is that this is not the only node. We need much more nodes. But maybe Carlos, you can answer this question better than me. Please go ahead.
So the idea is to have just a single node that is going to be basically managing the camera. So grabbing the frame live, and then it's just going to push this into a topic. There's also logs in there. So right now they are just prints. But the idea is to have them into a log function that is going to send to another topic. So it's going to be a camera log topic, so that you can pick up in the monitoring class or master code. And then we are going to have another topic that can be parameters. So just to do kind of interface, so we can define input parameters for it.
Okay.
Yeah. And the idea is to have other classes, other nodes that that are going to basically get the camera, the frame. We're going to have the master code that is going to do synchronization of everything. The communication is going to be done through eCal, which is a communication layer. And so, yeah, just the same thing as ROS. It has nodes as well. It has topics, and so we can just push to those topics. Yeah.
Mm-hmm.
But what is
okay? So that's the software side. Should be. Sorry, Richard.
No, go ahead. Go ahead.
I was just thinking, should we do more testing, like outdoor testing of the photo exposure, or
Yes, but not.
should we wait?
Not on not on the workbench. So what I did here is just I sit with the camera for I think almost 3 months now. Every day I was sitting there for 6 hours with this camera, just to find out what is this thing doing. So I don't need this anymore, because.
But indoors, I guess.
Indoors, of course, indoors.
Yeah.
So I don't need this anymore. Yeah. But what we need is now, I need to bring this camera out, put it in the box, put it in with the hood on it, and everything is fine. The reason is to have it in an environment that is normal for the camera, which is day and night scenarios. We wanted to monitor this.
Yeah.
I need to have a ROS2 node that is producing something I can control from inside the house. I have a network connection to the station, and I want to have a ROS node here on my desk to see what the camera is doing and to have influence on the camera.
Have a live stream, basically.
No, I don't need to stream it. I just need the metadata. What is it doing?
Okay.
In which state is it? I don't need the frame data. I don't need to fill my network here with data. But if we control functions on the camera, which is in this code and which Carlos is implementing as a ROS node, is that we can control it. We see the effect. We can say, how much is the brightness in this particular frame that you just collected? What is the brightness error? Yeah. And see what the target brightness is, and compare this from daylight to dawn light to night light, for example. This is something we need to. Yeah. I need to log and to track and to monitor and to see what is the best situation for whatever light situation there is. Maybe it's not much. Maybe it's simple. Maybe it's just 2 parameters to control. I have to say I've never done it before, and I'm very much relying on what Christian's experience is here. But what I think what we need is, first of all, a ROS node that we can control from the outside or from a secondary
outside.
Windows, for example. Same network, not different networks, same network.
Yeah, what I've done with my is that I tested the multicast. So I have the orange connected, and I have 2 laptops, an older one and this one. And so the 3 were connected, and then I plugged in a camera in each one, and I was just broadcasting between the 3. But in this case, we don't need that, so it's just going to broadcast the parameters, and then we can record locally.
You mean you record locally the logs?
The frame. So the frame is going to be processed and recorded locally, isn't it?
Yeah, recording is an important stuff, but at the moment I think recording is, for Christian, recording is very much important, I get it. But I think, if you ask me, recording is... So we need an event to have it on record. For now, the camera is putting frames into a buffer in RAM, and you can process them, you can subscribe to, and you can use them and play with them or track them or put everything. But you need a certain condition to say, this is now an important event and I need to record this. And as long as we do not have this event detection ACA tracker, yeah, recording is important, but I wouldn't say that's of the highest priority for now.
Yeah, but we should think about the architecture for it, because in theory we can broadcast through eCal and have the recording done on a different platform, being on the PC or being on another Orange. But that's going to overload the network, the connection. And so the idea would be to record locally and then just copy the parts that we want. And then it's going to be in a loop, just in a ring buffer, let's say, of files. But yeah, we need to think about the architecture.
Yeah. I think...
guys, I have to go.
Yeah.
So see you next time. See you in weeks, I guess.
Yes, in 2 weeks. Okay.
Yeah.
Well,
thank you.
Yeah, thank you.
Okay, thanks.
Looks good.
Bye-bye.
Bye-bye.
So I stop recording so that we can go further on. Okay, guys. See you next time. Bye-bye.